NASA's latest announcement has captured the imagination of scientists, space enthusiasts, and the general public alike, as the agency unveiled the most detailed images ever taken of Comet 3 I/Atlas, only the third confirmed interstellar object to pass through our solar system. The release instantly sparked widespread fascination, not only because of the object's exotic origin, but also due to the unprecedented clarity of the imagery captured by multiple spacecraft. During a press conference held on November 19th, NASA officials emphasized that while the comet's origins may be mysterious, its presence does not pose any kind of threat to Earth. In response to waves of online speculation and conspiracy theories, many falsely claiming the object was some sort of alien spacecraft, NASA made it clear that 3 I/Atlas is behaving exactly as an ordinary comet should. Dr. Tom Statler, NASA's lead scientist for solar system small bodies, summarized the excitement surrounding the discovery by noting that the object expanded humanity's sense of wonder and possibility, encouraging people across the world to think about how magical and complex the universe could truly be. His remarks during the live stream resonated with audiences who have long been captivated by the idea of interstellar travelers visiting our cosmic neighborhood. The newest images of 3 I/Atlas were captured by several of NASA's most advanced observatories, including the James Webb Space Telescope JWST, the Hubble Space Telescope, and the Lucy spacecraft, each of which contributed distinct perspectives on the comet structure, composition, and behavior. These images revealed intricate details of its icy nucleus, its expanding coma, and the faint trail of dust streaming behind it as it streaks through space. The combination of multiple instruments observing the comet simultaneously allowed scientists to construct the most comprehensive portrait yet of an interstellar object entering our solar system. JWST, with its powerful infrared capabilities, was able to detect subtle variations in temperature and composition across the comet's surface, while Hubble provided high-resolution, visible light images that highlighted changes in its brightness. Lucy, although originally intended for studying Trojan asteroids, contributed invaluable data by capturing the object from a closer vantage point as it passed through the inner regions of the solar system. NASA shared a sample of these photos with the public, and many viewers were stunned by the level of detail visible when the images were expanded to full-screen resolution. Comet 3 I/Atlas was first discovered on July 1st by the Asteroid Terrestrial Impact Last Alert System Atlas Observatory, a program designed to detect potentially hazardous objects approaching Earth. While the system's primary mission is planetary defense, its continuous sky monitoring has proven incredibly useful for spotting unusual or unexpected objects, including interstellar visitors like this one. Scientifically, the discovery is extremely significant because only 2 interstellar objects had ever been confirmed before this: the cigar-shaped Oumuamua in 2017 and Comet 2 I/Borisov in 2019. With 3 I/Atlas now joining this rare category, researchers gained an invaluable opportunity to study an entirely different type of cosmic traveler, one shaped by forces and environments far outside our own planetary system. Unlike asteroids or comets that formed alongside Earth and the other planets, interstellar objects originate in distant star systems and carry unique chemical signatures that offer a glimpse into the wider processes shaping our galaxy. Despite the excitement, many people worried about whether the comet might pose a danger to Earth, especially given the intense speed at which it travels. NASA reassured the public that there is absolutely no threat, stating that the comet will not come anywhere near close enough to be hazardous. In fact, its closest approach to Earth will still be an enormous 170 million miles away, a safe and comfortable distance. This reassurance came after social media posts and fringe websites spread unfounded theories about the comet changing direction or hurtling toward our planet. NASA also addressed concerns about its recent pass near Mars, noting that while it did fly within only 19 million miles of the red planet in October, this trajectory was entirely predictable and presented no danger. The flyby did, however, offer scientists a valuable chance to compare the comet's behavior in the vicinity of another planet. Since its discovery, 3 I/Atlas has moved with remarkable speed. When it was first identified, The comet was clocking in at roughly 137,000 miles per hour. As it continued its journey inward, the gravitational pull of the sun accelerated it even further. By the time it made its closest approach to the sun on October 30th, its speed had increased to around 153,000 miles per hour, making it one of the fastest-moving objects ever documented near the inner solar system. This tremendous velocity is partly why interstellar objects are so difficult to study. They pass through our region of space quickly, giving scientists a narrow window of time to collect data. Fortunately, NASA had several spacecraft strategically positioned to capture the event. One of these was the Mars Atmosphere and Volatile Evolution MAVEN spacecraft, which contributed a composite gas spectrum image showing what NASA scientists jokingly refer to as science wiggles, a nickname for the distinctive spectral signatures of gases emitted by the comet as it heated up under the sun's radiation. In terms of its physical characteristics, NASA officials emphasized that everything observed about 3I/Atlas aligns perfectly with what scientists expect from a normal comet. It exhibits the typical icy nucleus, a frozen core composed of rock, dust, and volatile substances, and a bright coma that forms as these materials vaporize. As the comet approached the sun, the heat triggered the sublimation of ice, releasing gas and dust that expanded outward into a glowing halo. This coma became brighter and more pronounced the closer the comet got to the sun, a behavior seen in countless comets originating from within our own solar system. What makes 3I/Atlas unique is not its features, but its origin. The fact that it arrived from another star system gives scientists a chance to examine materials shaped by conditions unfamiliar to our local cosmic environment. The color, speed, and trajectory of the comet all match the expectations of an interstellar object following a hyperbolic orbit, one that ensures it will eventually leave the solar system and continue its long journey back into interstellar space. Earlier this month, confusion spread across social media as misleading posts and poorly interpreted imagery led people to believe the comet was changing color in strange and inexplicable ways. Several online outlets amplified this misinformation, suggesting that 3I/Atlas had suddenly shifted from red to blue or vice versa, fueling conspiracy theories and far-fetched claims about hidden cosmic dangers or extraterrestrial technology. NASA quickly dispelled these rumors, explaining that the perceived color changes were simply due to differences in observation methods and the natural brightening of the coma as the comet neared the sun. Earlier observations that made the comet appear red were based on a specific set of filters and instruments, whereas later analyses, including those used in a preprint study, showed that the comet is actually distinctly bluer than the sun. One of the study's co-authors, Qiqing Zhang from Arizona's Lowell Observatory, emphasized that there was no evidence whatsoever that the gas coma itself had changed color. Instead, the variation in appearance resulted from increased brightness as more gas and dust were released during the comet's approach to the sun. Such changes in luminosity are normal and expected for a comet heating up in the inner solar system, and they reflect typical behavior, not mysterious transformation. The public's fascination with interstellar objects like 3I/Atlas underscores a broader human curiosity about the unknown and the unexplored. Each time one of these cosmic visitors passes through our solar system, it presents a rare scientific opportunity, one that can deepen our understanding of how planetary systems form, evolve, and interact across the vastness of space. While they come from unimaginable distances and move at extraordinary speeds, these objects carry with them clues about the building blocks of other star systems, potentially including materials older than the sun itself. The study of 3I/Atlas will continue over the coming months as scientists analyze the extensive data captured from multiple spacecraft, hoping to piece together a more complete picture of its origins, composition, and long-term trajectory. For now, the comet's brief appearance has already provided researchers with invaluable information and the public with a renewed sense of cosmic wonder, reminding us once again of how vast, complex, and awe-inspiring our universe truly is.